Welcome to our today's learning module Regression Discontinuity Designs. In this module, we'll review Regression Discontinuity Design, or RDD. We will also review that while a Regression Discontinuity Design, RDD evaluation, like a difference in difference, can be conducted with existing observational data, it's not always a feasible alternative to an RCT. The module will cover these 8 topics. 1. Introduction to Regression Discontinuity Designs. 2. Implementing the Regression Discontinuity Designs approach. 3. Linear functional form. 4. Other functional forms, polynomials. 5. Non-parametric approach specifications. 6. Fuzzy RDs. 7. Manipulation of the running variable. 8. Review of Regression Discontinuity Design. Therefore, as we progress through the module sections and topics highlighted above, keep in mind the following questions for reflection and comprehensive learning. 1. When would you implement the Regression Discontinuity (RD) approach and how? 2. What are linear and polynomial function forms, and when would you use them? 3. What are non-parametric specifications? 4. What is fuzzy RD, and when would you use them? 5. How and why would you manipulate a running variable? I urge you to follow systematically as we cover the highlighted topic, and am sure you will greatly advance your skills in monitoring and evaluation. As a reminder, make sure you have subscribed and turned the notification on so that you may not be left behind in the learning process. Saying that means I understand the major weakness in human learning is the accumulation of uncovered information. Join us and let's sharpen our professional skills. Introduction to Regression Discontinuity Designs. In this module, we'll review a second quasi-experimental technique of program evaluation, the so-called Regression Discontinuity Design, or RDD. In an RDD, we compare two groups of individuals, one exposed to the intervention and one not, that are as good as randomly assigned, if not exactly so. While an RDD evaluation, like a diff and diff, can be conducted with existing observational data, it's not always a feasible alternative to an RCT, either because the exposure to treatment turns out to be not as good as random, or because the amount of data you need is much larger than in a typical RCT. But let's back up a little. We know by now that in order to estimate a causal effect of an intervention or program on an outcome, those who are exposed to the program have to be statistically similar to a comparison or control group who are not treated. More technically, treatment should not be correlated with anything that might be associated with the outcome variable or with its response to the intervention. Randomization in an RCT ensures that this condition is met. Treatment assignment is by design, at least in expectation, not correlated with the outcome or its response. But most programs are targeted to either those who need them, say, because their outcomes are considered worse than others, or because it is expected that the intervention will have a bigger impact on them. For example, nutritional supplements might be targeted at underweight kids who need them, or high-energy food might be made available to high-performing athletes who can make better use of it. Similarly, extra tutoring might be targeted at kids having trouble at school, or scholarships might be reserved for gifted students who can make the most of further education. And these kinds of situations, with and without comparisons, are not going to provide useful information about the impact of the intervention in question. Why? Because the kids who get the nutritional supplements get them because they are underweight. And the kids who get the extra tutoring get it because their test scores are low. So a with and without comparison would be conflating two things: any effect of the intervention and the pre-existing differences between those who did and didn't get the intervention. Sometimes eligibility is determined on the basis of an index or score of some kind, a measurable underlying characteristic of an individual. For example, kids with height for age or weight for age z-scores, commonly used measures of nutrition, less than a certain value might be eligible for a health intervention. Or students with test scores above a certain level might receive a scholarship. Or villages with a poverty rate higher than a certain value might get public investment. These scores or indicators are sometimes called running variables. As the value of this running variable crosses a threshold or cutoff, eligibility for the program switches, from off to on if you like, in a discontinuous fashion. It would definitely be a mistake to compare the average outcomes for all the eligible individuals with those of all the ineligible ones. On average, certainly the two groups are likely to be different. Apples and oranges, if you will, but around the cutoff, the two groups might be pretty similar, close enough to the same, to warrant thinking of those who are just eligible as the treatment group, and those who are just ineligible as the control group. And even if they are not the same in terms of their underlying characteristics, those characteristics might at least be assumed to change continuously as the threshold is crossed. Indeed, if there was no intervention, we would likely expect the outcome of interest itself to differ across individuals, if at all, in a continuous or smooth fashion as the threshold was crossed. On the other hand, in the presence of an intervention, eligibility for the program changes discontinuously at the cutoff. It jumps from ineligible to eligible. If, comparing individuals just below and just above the cutoff, we see a corresponding jump in the outcome of interest, then we might well infer that this jump in an otherwise continuously changing variable is directly associated with a discontinuous exposure to the intervention. This is the idea behind the regression discontinuity, or RD method of assessing impact. It looks promising. You would think that a big jump like that must have something to do with the sudden change in eligibility status. Our limitation, however, is that we can't say much about the impact of the intervention for those who are far from the cutoff, so we learn about a select subset of the population. Keep turned. The coverage of the second topic, on implementing the regression discontinuity designs approach, is coming soon. Until we meet for the next topic, review the learnings while trying to answer the reflection questions shortlisted in the beginning of the topic.